Thank you, Dr. Subhash. At the outset, I'll differ from his statement. The machine is not the most important. You are most important. You will be doing the surgery, and the patient will be holding you responsible for the surgery that you're doing, and not the company who's provided you the machine. So my topic is introduction about the machine and phagodynamics. We'll briefly just go around it. And although I'm talking about machines, I don't have any financial interest in the machines. Parts of a phaco machine: you have a console, a foot switch, tubings, and a probe. I think this is familiar. And then how those parts function: we have a bottle with an irrigating liquid, an irrigating tube, an eyeball, an aspiration tube, and an aspiration pump. These are the components of a phaco procedure. And what does the machine do for you? There is an infusion, aspiration, and the most important, phacoemulsification, which again is you either doing a trenching, or you're holding the pieces, or you're chopping it, emulsifying it, and finally cortex removal. Now the infusion, the first aspect. There is a formula, forget the formula. What you must be remembering is that the infusion depends upon the height of the bottle. And that is, the bottle height is the pressure, and the diameter of the tube, which is the radius, and that is radius to the power 4. So a small difference in the diameter will make a lot of difference in the inflow. Again, for aspiration, it is the same formula. Aspiration depends upon the pressure, which is determined by the pump of the machine, and again the radius of the tubing that you are using, plus there is some outflow from the incisions also that you have to take into account. So the idea is to keep a positive pressure in the AC. The chamber should be stable, and for this, the inflow should be more than the outflow. Now during surgery, many things are set in the machine, you cannot change it. So to change the inflow, all you can do is to change the bottle height. To change the outflow, all you can do is to change the flow rate. Remember, changing the vacuum will not affect the flow. Vacuum will affect the hold of the piece. Now the most important part of the machine is the phaco power. A hand piece contains piezoelectric transducers, which transforms the electrical energy into mechanical energy. And this is usually in the range of 20,000 to 40,000 hertz. Again, there is a formula for the phaco power. K is the impact surface, that is the thickness of the rim of your phaco tip, the outer diameter minus the inner diameter, the area that comes into contact with the nucleus piece. Frequency is set by the manufacturer. Stroke length is how much is the amplitude of the phaco tip when it moves while you're using power. And this is the only modifiable factor. This is the only thing that you will be changing to modulate your phaco power. So the only way to change the phaco power is to change the electrical power to the handpiece, and hence the stroke length. This is the only thing that is in our hand. There are different modes for different steps of surgery. This is just a screenshot of the machine. When we are doing the trenching, you have aspiration, vacuum, and the power set, preset. And below what's shown as 0 is as you start the machine, how much of it is you are using will be displayed there. This is not a video, this is just a picture. Again, phaco 2, that is the chopping part, when you hold the pieces. This is the 30, what is showing 30 is the flow rate. The 330 is the maximum vacuum that can be created, and 45 is the maximum power that will be used. Right now at this point of time, this is what is being used. And again in emulsification, the same thing. These are the preset in the machines, and this is what the surgeon is applying right at that moment when this picture was taken. Now how does the power modulate? Different modes. We have 3 types of basic power modes: continuous, pulse, and burst. Continuous is the most basic form of power. It is a linear control of power. Maximum phaco power is set and then delivered between 0 to the maximum preset level. That means as you go on pressing your foot pedal, more and more power is delivered. And at the end, when you press it totally down, the maximum preset power is achieved. Pulse, again, there is an on time and an off time. So when you are pressing down your foot pedal for power, for a certain split second, the power is on, and then for a certain split second, the power is off. thereby reducing the total amount of power which is used. And normally, the machine have a default of 50%. That is, half the time it is off, half the time it is on. Now, pulse, the setting is also how many pulse per second. So, in the top one, if you see, the duty cycle is 50%. So, as much it is on, it is off. And this is one pulse, then another pulse, then another pulse. But if you change the duty cycle, the pulse remains the same. But the on time is reduced and off time is more. So, here you are reducing the power. You are using lesser power at the same pulse. So, this is the changing of duty cycle. And what is the burst mode? Burst mode is as you start pressing your foot switch, it initially functions as a pulse. But as you go on pressing it, the off time reduces, on times becomes more. So and so that when you have finally pressed it totally down, the off time is absolutely absent and it becomes a continuous mode. The next aspect is the vacuum. Difference in the fluid pressure among the 2 points, that is, your tip of your needle and the anterior chamber. And this is created by a vacuum pump, and we have machines with 2 types of pump, the peristaltic pump and the venturi pump. The peristaltic pump, considered to be safer, is a flow-based, while a venturi pump is a vacuum-based. In peristaltic pump, the vacuum is created by occlusion after occlusion of the tip, whereas in the venturi, the vacuum is created instantly the moment the pump is on. So, a peristaltic has a slower rise time and hence considered safer. A venturi has a faster rise time. Flow is constant until occlusion in the peristaltic machines, but flow varies with vacuum level in a venturi machine. This is the basic of a machine. But today, if you go to the stalls, the machines that are available have added some more features. And why are these features added? Why are the developments done in these machines? Just to increase the cost? No. The only purpose for any advancement in a phaco machine is basically to protect your posterior capsule, thereby minimizing the chances of rent, and to protect the endothelium, thereby reducing your corneal damage. And this is done by reducing the phaco power usage. The lower power you use, the less power you use, the safer you are, preventing surge which will cause rent, and maintaining AC in a good way. The new generation machines that are available these days have added a torsional phaco, that is a transverse on an elliptical movement of the phaco tip. Why? Because in the longitudinal phaco, the power was being used only for the 50% of the times. When the tip was going forward, you were using that power. But as the tip was receding, power was still being generated, but that power you were not using. So you were using only 50% of the power. So the technology, they developed the technology that we can use more of it by moving the tip horizontally or elliptically. I mean a circular motion or a transverse motion. So a to and fro motion and a transverse motion compounded can give you a better emulsification with a lower power. And now you have recently a machine, I don't mind, the name is Centurion, although I don't have it, so there's no financial interest. They have introduced a concept of active fluidics. Now, till now, the irrigation was totally dependent on a gravity. The higher your bottle is, the more your irrigation is. But this machine does not use the gravity for infusion. This is a pressurized infusion instead of gravity infusion. Here you put your BSS pouch into a slot, and by 2 plates, it is compressed to create a pressure for the inflow. So the surgeon can select a target IOP. This reduces post-occlusion surge, better chamber stability, and lowers the risk of complication. Again, all these developments are for those 2-3 points that I had mentioned. So with active fluidics technology, the surgeon selects the target IOP, the patient eye level, irrigation factor, and IOP ramp. And the system responds by, throughout the procedure, the system maintains the surgeon selected target IOP by actively monitoring and responding to the changes in vacuum pressure, irrigation pressure, and the pump speed. The next important part by which you are actually doing your surgery is the foot pedal. Most of you must be knowing it. You press it a bit, position 1, irrigation is on. Position 2, irrigation and aspiration. Position 3, as you go on depressing it further, infusion, aspiration, and power. And then you will be using a phaco tip inside the eye. That is the part of the machine which goes, the rest is outside. Tips are of various degrees, 60, 45, 30, 15, 10. I think most of the people are using 30-degree tips. I use a 15-degree tip, but commonly 30 and 45-degree tips are used. Now, the degree of the tip, how does it affect? Occlusion is not achieved if the grip is poor. So the tip should face to face hold or touch the piece. If it is tangential, there is some fluid coming in, you will not get a good occlusion. And that is called a 0-degree effect. If you can see this diagram, this is a 0-degree tip, perpendicular to the piece, it has totally occluded the tip, and you'll get a very good hold. But the same can be achieved by a 45-degree tip if the pieces are oblique. But in a vertical piece, if you apply a 45-degree tip at 90 degrees, you won't get a good hold. And again, for a 0-degree tip also, if the pieces are oblique, you are not going to get a very good hold because there is not a 0-degree effect. So a 0-degree piece is fine. For any piece, you can get a 0-degree effect by aligning the surface of the tip to 90 degrees to the nuclear pieces here. Then you will be using choppers. This is not a machine but an instrument from your left hand. You have to be ambidextrous for this surgery. You can have a single end chopper or the David Chang chopper, which has got a sharp tip and a blunt tip at both ends. Choppers can be personalized. You can have a 0.75 length, you can have 1.25. So this was the basic of machine, and the further steps will be told. But since this course is a Prarambhika, and I believe it is for beginners, although many of you must be experts, away from the phaco beyond the borders. That is the loose zonule, hard nucleus, small pupil. Don't go into these beginning if you are going to begin phaco. Thank you very much. And now we move on to the actual surgical steps of phaco.